In our continuous efforts to help bring the lab to the field, we are pleased to present the first ever 12-volt hammer mill field kit. Within minutes, you can easily prepare your samples to generate lab quality data where and when you need it. I will let my colleague, Mr. Marc Duparat, demonstrate this for you.
Preparation for using the mill begins with chipping pieces from the rock sample. Once you have some rock samples, place them inside the crusher base. With the chisel attachment placed into the holder, break the larger pieces into smaller chips. Continue to place enough pieces into the base until you feel there is enough material which represents your sample. Once the pieces are less than about 2 centimeters in diameter, insert the flat crusher attachment into the holder. Several blows of the hammer should be enough to reduce most of the rock to less than 8 millimeters, which will then need to be sieved. Transfer the material in the bottom of the crusher base into the sieve. You can see here that the rock is now the appropriate size to deliver to the mill. Once the mill is connected to either an automobile battery or some other 12-volt DC power supply, the mill must be powered on and the sample bag attached to collect the milled material. Slowly feed the sieved material to the mill with the mill feed valve in the closed position. You can see here the mill material being collected in a sealable bag. Once the mill sounds like it is done milling the material, you may shut off the mill with a switch on the back and then remove the sample bag. Here you can see the fine powder generated by the mill. With this material, you may now generate a pressed pellet. Now we are ready to press a pellet. Assemble the press as outlined in the user's manual and feed the sieved sample directly to the pellet press. Transfer approximately 1 full tablespoon from the sieve base to the pellet press. Gently tap the side of the pellet press with the hammer to move the powder to the base of the press. The inside of the pellet tube must be free of powder before the piston is inserted in the press. Skipping this step may result in the piston getting stuck in the pellet press, and it can be very difficult to remove. Gently move the tissue down the tube with the piston. You must make sure the pellet press is on a firm surface. Firmly hold the pellet press as shown. Gently tap the piston with the hammer to further compact the material. Then, once the material does not seem to compress anymore, give the piston 1 solid blow with the hammer. Do not hit the pellet multiple times or you will destroy the pellet. Now you may remove the piston, then loosen the screws to separate the base from the tube so you can remove the sample you just pelletized. Make sure you invert the press so you do not lose your pellet. The stainless steel pellet press must be at least half filled with material for proper analysis. If it is not half full, you must repress another pellet. Now you are ready to analyze the pellet. Place the pellet directly on the Niton FXL or in the Thermo Scientific field-made test stand, and with the analyzer installed, close the lid. You can now enter the name of the sample on the touchscreen of the analyzer for later identification, and then click the trigger to begin your analysis.
When you combine the high throughput of our Thermo Scientific Niton XL2 Gold, Niton XL3T Gold Plus, and Niton FXL instruments with the benefits of our sample prep tools, you too can change the way you work. Whether you want more information, have questions about how our equipment can help benefit your company, or would like to schedule an on-site demonstration, please visit thermoscientific.com/Niton.